Okay, and I'm back. So now I'm just making sure that everything is working. I completed section 1.2. We're going to 1.3. I want to make sure that everything is, yeah, I got sound. Good. All right. So just the usual things I do if you've seen any of my other streams. This is a parasocial stream. I'm going to do math. I'm going to ramble. I'm a student, not a teacher. If I answer something correctly, that's great. If I get it wrong, I will try to figure it out. I do get lost sometimes. Totally normal stuff for math. Anyway, this is a class I have not passed, but the book is The Book of Proof by Richard Hammock. The link is in the description. It's an open source, well, not open, it's a Creative Commons book. And this is a class that I dropped in order to focus on work, but I'm going to retake it in the future. Meanwhile, I'm just polishing up my skills. So yeah, let's do that. Right now, if you look at it, this is where we left off. All right, I'm just going to keep rolling through here. Gonna add this. All right, and then I'm gonna take off a minute. Let's just start this over. Save. Okay, there. I'm gonna clear up. All right, we are now doing 1.3, and we right. There's A, B, and C, but to be honest, it's like I'm not gonna say that. Hang on a minute. I'm just gonna roll through them because there's like it only goes to 15, and it's like I'm not gonna. That's my dog. He's running outside. We have a yard, and my uncle let him out. Yeah, he does it at night because we got like foxes and stuff, and he's very protective. Okay. Yeah. Let's just roll through all these. All right. This is a little different. So we're listing all the subsets of the set. All right. What is the how many subsets would there be in a set? Well, that's an important question. You'll understand what that means in a minute, but yeah, what we're gonna do is this. We are gonna use a principle. We're gonna say, if we want to know the number of subsets, doesn't tell us what they are, just tells us the number. We're gonna say it is 2 to the n. Okay, 2 to the nth degree. In this case, n refers to the number of n equals to the cardinality. Okay, so we're saying n is the cardinality. There's cardinality means the size of the set. The size of the set contains 4 items. N equals 4 in our case. So this, so we're going to say the cardinality is equal to 4. All right. 1, 2, 3, 4, 4 items. Therefore, 2 to the 4th power is 16. Okay. 2 times 2 is 4, times 2 is 8, times 2 is 16. All right. We expect 16 items. All right, so this one is a simple one. Very, very simple. We are going to just list the items. Let's just answer this. And so we want to know, hold on a minute. So this is a set, and we're going to subdivide it into other sets. We have to write that correctly. The first thing is going to be the empty set. Now, when we write the empty set, this also just means an empty box. Okay? There's a box. It's not 0, it's a box. But there's nothing in the box. All right? That's item 1. We can take our first item, which in this case happens to be 1. We can make a set of it. All right? We do the same thing with 2. You see where I'm going. These are called singletons. All right, 4. All right, then I'm going to switch to a new line. We're going to say 1 and 2 doubletons. 1 and 3. 1 and 4. And also, we're going to say, now, by the way, 1 and 2 and 2 and 1 is the same thing. So it's a box. You can shake the box. The items will still be the 2 items in there, even if you change around their order. But so what we can do is, okay, so that's 3. What's the cardinality of 2 items, right? 2 times n is 2 times 2 is 4. There's listed 3 items. So the one that I haven't done yet, wait a minute here, hold on. Am I saying that correctly? Well, we know that 2 and, oh, okay, hold on. This is, okay, disregard what I said. That wouldn't work in this case because this has to do with, this is, we're taking a set of 4 items and we're mixing them in size of 2. So it's a little different for this part, but that's fine. We're talking about 16 total. 2 and 3. 2 and 4. And also, I'm going to say 3 and 4. Let's see here. So we have 1 and 2. 1, 2, 3, 4. 2, 3, 4. 3, 3, 4. And also, let me see here. No, that should be correct. So we'll go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, we're getting close. 5 more. Okay. 1, 2, 3. 1, 2, 4. 2, 3, 4. And this is the tricky one. This is the one that you forget about. 1, 3, 4. And finally, 1, 2, 3, 4. The full set is itself a set that counts in this thing. Don't forget, we have one open one right here. So we have to close it. Okay. Let's count them real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. And that matches up with our expectations. So far, it should be correct. Let's take a look. 1.3. 1, 2, 3, 4. 1, 2, 1. Just let me count them also. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 15, 16. Yep, 16. Okay, and listing their elements between the braces. Okay, the subsets. The only thing that this is what I wrote here is a set of subsets. And the question asked me to list all the subsets. So I wrote it a little differently. I wouldn't have gotten any deductions for it. At least reasonably, I wouldn't have expected to get a deduction for it. You never know. But what I wrote, I'm just going to take this off. I wrote a set of subsets. They wanted just a list of the subsets. Okay, so that's fine. What I made is, it's a set. It will still contain all the subsets. It's still a list of the subsets, but I just turned that into a set. So basically, it doesn't matter. There. This is how the book has it, and that's fine. It's still the same thing. Just I put an extra, turn them into a set. That's fine. Whatever. Okay, good. Let's continue. Let's see. Okay, just a second here. There we go. Good. Okay, we're at 1.3 now. So that was question 1. All right. This is going to get more interesting. Good. All right, here we go. So we now have for 3. Okay, so we have there is a set. So let's read this right. Okay. This is our main box. This is our main box, right? Okay, inside this box exists another box. Inside that box is an item. But whenever we talked about how many items are actually in the first box, so like when you have a box and you can have like imagine you have a wrapped present in there, and there could be any number of things like the Russian dolls. They could be nested in there, and that could be one of the presents wrapped up. But as far as you open up the shipping box, and inside there's a present that's wrapped in there. You don't know what's in the present. You just know it could be empty, but that's one. So the cardinality of here is we determine that by taking this off and we count the complete braces. So then the cardinality is 1. There's one item here, okay? What is now, in terms of the size of the number of expected items, remember, we're going to say it is 2 to the n. In this case, the cardinality is the n, or the number, so which is 2 to the first, which is 2. So in that case, we just have the empty set, and we have this full thing. Right? Okay, good. List all the subsets. Now, notice I'm not doing this. That's a set of the subsets. They just said list them. Okay, so let's just do that. All right. Yes, the book agrees. Good. All right, and cool. 5. Okay, this is a fun one. This always gets people until they're used to it. I see what you did there. Okay, what is that? So remember, this is an empty set. This is the same thing as having empty braces like this. These two are identical. So now, let's imagine what we have here, right? We have a box, and inside this box is another box. So we have a box inside a box. What is the cardinality of this thing? Well, we scratch this, and inside we have 1. So the cardinality is 1. And then so we say, so we have 2 to the n, which is 2 to the 1, which is 2. So that means we are listing the sets. So we are going to say this, the empty set. It's not this. An empty set is just this box by itself. That's the empty set if we just took that box by itself and we took the sub box out of it. If we remove that, that's the empty set. And then we have our full set of the box with the empty box in there. All right. All right. Let's see. Take a look here. Yes, the book agrees. Cool. All right. Like I said, this is it's a little faster. Okay. Now, okay, this is mind melting if you're not used to this, if you've never done this kind of stuff. I mean, I try to explain it, and it's good for me too. You learn a lot better when you're forced to explain things and try to make them as understandable as possible. And yeah, it's just, I know when I was first learning this and I read this, and it was so hard to look at it. It was so hard. It's just, and that's why I took math. Why I made it my major, because the other stuff that I took, I was able to breeze through. And when I got my associate's degree, I mean, it wasn't purely breezing through. When I was skating competitively, I couldn't study much, and I would always get like bad grades, like W's or F's. I would drop the classes and I would come back and retake them. It took me about a decade to get my associate degree of computer science, but finished with a 3.93 GPA for all that's worth. Anyway, only to be a landscaper / handyman because the economy changed. And at the end of the day, it's whatever pays you and gives you the most freedom. Anyway, um, by the way, I feel very vindicated. If you happen to see the new South Park episode, um, was it joining the Panderverse? So the plot B was how no one knows how to do anything anymore, and the handymen all become billionaires. It's pretty on the nose, but it's pretty close to the truth. I'm not saying we're billionaires, but there definitely is a demand for, like as a skating coach, I'm far less in demand, even though I have a much higher amount of invested time into that versus my handyman slash landscaping skills. Although at this point, I've probably done close to the same amount between them because I worked a lot as a handyman slash landscaper while I was skating, but it was on and off. I would do all kinds of different jobs. Like one of the jobs I did when I was down in Florida a couple of years back, I was a bit of a landscaper. I had a bit of a coach. Well, actually, no, I wasn't coaching. I wasn't paid down there. It was just training with my partner because couldn't get on the staff there. They had just like coach protections because it's very easy to have more coaches than students. But what I was there is also I was a server at Texas Roadhouse, and I could still walk in there and get that job back because they love me there. It was a fun job. Anyway, here we go. Okay, this is our Q, or we have our fractions. All right, and then naturals. Can I do this any better? There we go. All right, so the way the book tries to fool you is they want to confuse you by what's in the box, right? What's in the box? What you got to remember is that let's find the cardinality. Start there. Always start there, okay? So we scratch these, the first two ones, and then we count the number of items in there. Okay, hold on. Why is this thing? Am I losing? I'm getting, there we go. Okay, may have been disconnected there for a second. I don't know what's going on. Anyway, right. So we have 1 and then we have 2. So we have a total of our set's cardinality equals to 2. So we have 2 to the n refers to the number of different the subsets, which in this case we take 2n as the cardinality. 2 to the 2, which is 4. We're expecting 4 separate items. We're going to list them. First, we'll go with the empty set. Okay. Then afterwards, we're going to list the singletons, the set of the reals. So essentially, we just did that. We're keeping everything else. And then we are going to go disregard what's in this set. It's not important. And the fact that it has multiple items is fine. It still counts as 1. Q, there we go. And actually, Q's, what am I doing? There. No, oh, too much. There. That's correct. And Q, and there we go. So we have fractions, and then the irrationals, and then we have naturals. R contains irrationals, Q contains rationals. So anything that's, you can put it in a fraction form, like you can't put pi in fraction form to where get a definitive number. Like you can say pi over 2, but it's not going to give you a rational result. It'll give you an irrational result if we're ever continuing, in other words. All right, so then we have, so we have empty, we have 1, 1, and then finally the whole thing. We have and those are the large letters refers to the types of sets that we use in this thing. Okay, so we have 4 items. We have the empty set, we have the singletons, and we have the whole complete set. All right. 1.3. we are in 7. Check to make sure I wrote it correctly. Oh, okay. Hold on a minute. Hold on. So the only mistake I made, I would get slightly deduction for this small point deduction, is that I wrote it this one right here. What I should have done is I'm going to correct this real quick. And this was just because I was kind of blowing through this. Remember, we're creating subsets, so you need the subset brackets. The fact that there is already exists in the box, you still have to put this in this new box, because when you create subsets, you're basically knocking an item off. And okay, and this is what threw me off. I see what threw me off. I drew this wrong there, because now, like, if you knock this off, that's our answer right there. You just move this up. It just moves closer. That's it. That's how you do it. Okay, good. So we answered that. Okay. We're going to have now we're going to B. That was A. B's only got 2 questions. I'm not breaking up into A, B, and C here. Okay. All right. Okay. Large X, believe. Okay. You have to forgive me if me reading set notation is going to be a little funky here. But I should be all right. This is a big X. Okay. So the set of the set I want to check on something real quick. I'm just going to read it. It won't matter. I'm either going to read it correctly or a little off, but not enough to where we won't be able to answer it. Sorry. Okay. All right. If I'm a little sleepy and this sound groggy, it's because it's close to my bedtime, and I pulled this past week. I worked a lot, which is good. It's good money, you know. Money's good. Money's great. Yeah, like I know I work 70 hours a week. That's normal. I usually work every day. And then like yesterday, I did 2 different jobs. One was 3 hours, leaf cleaning, and the other one was a moving, and that was like 11 and a half hours, I think. So, and that was very, very intense. Unlike like the leaf moving, yeah, it's hard work, but it wasn't super intense. But this moving, it was on a very tight schedule. It was a last minute thing that they needed help with, and it was a regular client of mine. So yeah, it was an adventure. And yeah, I was a little tired from that. Slept maybe like 5 hours. I was out working again today. Yeah, and then out working again tomorrow. And coaching. Got to coach tomorrow. I coach twice a week. And I'm just going to write this out, then I'm going to read it, and then we're going to be okay. Okay. All right. Get ready to panic because I don't know what this says. No, I'm just kidding. No, this is fine. All right. So I might not read it precisely, but I know what the gist of it is. So the curly braces, of course, is our set notation. This is and we're gonna say this: the big X is the set. So we're saying the set of X, such that the set is this is the union, or hang on, big C. Hang on, I have to look that part up real quick here. Oh, okay. The subset, right, is the subset of 3, 2, and A, and the cardinality of X is 2. So the set X, the subset, the set X such that it is the subset of this set 3, 2, and A. and that x, so in other words, it has to contain those elements, and the cardinality is 2. That means we're going to go with, we are going to say that we want the doubletons. Okay, so we're going to say 3 and 2. And we're going to say 3 and A. And we're going to say 2 and A. Those are, that should be the correct answer. I'm going to check that real quick. Oh, right. It is the set. They wanted the set. So the large X means the set. The set such that the set, it contains, or no, this is subset. Okay. We want the set X such that the set X is a subset of this set. Subset of this set. And that the cardinality, the size of the subsets that we're spitting out within it, of each of those subsets in our set, are going to be 2. So there's only 2 items per each of the subsets. This is where we start to melt the brains a little bit, you know? It'll only get worse from here. I promise you that. Anyway. So yeah, now it's correct. So I'm going to say this. This right here. Let's see, let's make this a little less crazy, right? That refers to this, okay? So that is the set. Now, over here, such that X is a subset of 3, 2, and A, okay? It's a subset. Now, the subset, if we didn't have this part, scratch this, then we would be like this. We would say this, and then we would say, it would have to be a set. And then, it would be this, and then it would be 3, and then, then it would be, I am writing chicken scratch, I know, and then so forth, our usual thing that we did, right? But that's not what it wants, and my thing crashed. Okay, so basically, what I'm saying here is that, I have to do some painting over here. Okay, so what happens is that this is a second condition here. It's not just a subset of that, because then we can just write the whole set. Instead, the set that we're making, this new set X, it has to have a cardinality of each of the items in it. It has to have a cardinality or a size. It's limited to 2. Each box has to contain at least 2 items within this big box. So basically, we're saying this right here, this is a box, right? Okay, now this one here is a box, and we can subdivide the boxes any number of ways. But in this case, we want to subdivide the boxes such that each of the sub boxes contains 2 items. So we're going to say 3 and 2, 3 and A, 2 and A. Okay, that's what we did. This whole thing, it means this. So we got a box, and it has to contain these elements, and that means a subset of this set, and the cardinality or the size of the sets, these boxes within this bigger box, which is the X, is that they has to be 2. So yeah, I know, a little brain melty, but yeah, now I think we got this. I mean, I understand what it was saying, but explaining is much harder. It's good for me too, because it really forces me to, double check everything that I'm saying mentally. Am I explaining it correctly, or do I sound like a madman? And don't get me wrong, I have never claimed that I'm sane. Okay, just remember that. Okay. All right, let's continue here. Such that. is a subset. The set of X such that X is a subset of, let's call this set Y. Or no, the X just means a set. The set, which is a subset of this set, 3, 2, and A again. A could stand for action figures for all we know. That could, this could be anything, right? And the cardinality, this is a strict requirement. It absolutely has to be this. There's no fudging, and it has to be 4. So, well, what's the cardinality here? Well, the cardinality is 3. So remember, we scratch these, count 1, 2, 3. So there is no such thing. So the answer, there is none. So we can just say nothing. This set is going to be just, that should be the correct answer. They might write it a little differently. They might say, let me see here. No, the book agrees. Yeah, I can't back up, so I'm just going to X this out and restart Paint. Paint crashed on me. Okay. Hang on. Yeah, hang on. I'm going to have to do it. Okay, I'm going to relaunch Paint now. All right. Hang on a minute. Go back here. All right, can you see me now? All right, I think we are going to be good. There we go. Present, share screen. Paint. Okay, that's it. Good. So I just had to restart Paint. It crashed. I don't know why it does that, but whatever. Okay, we're in C now. 1.3. Doing pretty good. We got 2 questions left. And that will complete 1.3. R3, which is the subset of R3. Decide if the following statements are true or false. Explain. Every set is itself a subset of itself. In other words, remember how we did, how whenever we would write out the subsets, and the final set I was do was be the whole set. So basically, true. Okay, I might not explain that correctly, but I would say that's the correct answer. Yes, they wrote, because any set is a subset of itself. So yeah, just different words, but the answer is correct. All right, we doing good. We doing good. All right. All right, and that was 13, and let's do 15. All right. Let's melt that brain, people. There we go. Not even halfway done writing this. Okay. All right. Set. So we have here, we have x, y coordinates. So the ordered set. Okay, so then we have set the ordered set such that r squared, or the region of, in other words, this is an order set of x, y existing in R2. So this is our real space that we're using, reals, meaning that the whole thing, it can be anywhere x and y. And this exists inside there, okay? That exists in there. Such that, colon is such that, x minus 1 equals to 0. Well, first thing we got to do is we got to solve this thing here. What is that? So we take this, x minus 1 equals to 0, which is the same as x equals to 1. Okay. So that means the x is 1. Y could be anything. It's not given to us. So that means any y, but this line is what we want. So now, is this a subset of the set, ordered set x and y, such that, or which contains the real space of R2, x, y, such that x squared minus 1 equals to 0. Okay, well, let's solve that. X squared minus x equals to 0. Okay, I think that might be a parabola. Okay, so hang on a minute. Give me a second. We have to factor it. Well, the way we factor this is we're going to pull an x out. I'm going to say 1. I'm going to say x minus 1 is equal to 0. X equals to 0. X equals to 1. All right, that's our answer. So we just factored it and solved it. Basically, I pull an x out. If we multiply x times x is equal to x squared, x times -1 gives you x. So now, then we just take each of those and we solve them. Because it's 0, either of these solutions, if this is going to be 0, in other words, if this solves to 0, then it'll take out the x. X could be anything. If the x equals to 0, it'll take out this equation. But there could be more than one solution. So we know this x has to be 0. If this doesn't exist, it only has the one solution. But because there's the -1, we have to solve that, which is 1. So now we have it. So where the answer now is that x is going to be 0, which is right here. So x is 0 and x is 1. Okay, this is going to be 1 and this is 0. Okay, and this is 1. Okay, there we go. So the question then is this a subset of this, right? Is it? Well, we have the x on a number line on 1, and it is a subset because you can find it right here. It's a 1-to-1 match. It exists there. So yeah, no, we're good. Yes. Yes, it is a subset. Let me go here. This is true. Okay. That is true. Think about this for a second. Okay, and just since we're still here, um, so just thinking here, if now here's a solution here. No, this is well, let's stick to linear algebra later. I don't want to get into linear algebra when we start about talking like subsets. A lot of there is how lower dimension space, how it maps, how it exists within higher dimension space. Just like even think about two-dimensional spaces are slices of three-dimensional space, and one-dimensional spaces are lines slicing through two-dimensional space, right? So basically that like x equals to 1, that is a one-dimensional line slicing through two-dimensional space here. And these concepts, they're very important in math. But yeah, I'm going to stick to what the book is going on here. I don't want to go off too much of a tangent, just because if I do, it'll be just, I can take us to some wild areas, and I want to stick to examples and just follow this thing because once we get to the end of this book, we'll start another book. It'll be fun. I think this is going to be a lot of fun. Okay. Yeah. Next, we have power sets, and that's going to be in 1.4. And then we have union difference 1.5. All right, cool. Yeah, we might be able to get through both next time. Maybe not both. Yeah, it's kind of big though. That's the problem. 1.5 is big. 1.4 is not. But yeah, this completes 1.3. We got through 2 sections today, which admittedly they weren't very big, but hey, we're making progress. We're getting there. All right. Well, I hope you guys enjoy this. Have a good night. I will see you next time.